Okay, here we are, on Monday the 13th, and we have to do energetics too, which we kind of started on Wednesday, but didn't get a whole lot done. So doing that and some amines, hopefully. Maybe the amines will have to wait. I mean, I don't know. Amines is kind of a weak topic, so maybe I should focus on that and then go back to energetics. Because I have done 50 minutes of energetics this week, which is not loads, but it is some. So maybe I will focus amines. Yeah, I'm gonna do that. Okay, so I'll be back when I've got up some amine stuff. Okay, so I've got up the oh, I need to switch to that window, sorry. One moment. Here we go. These are amines notes. Includes amides and amino acids. Okay, so oh, naming amines. These end in amine. Wow. There is, however, rather confusingly two ways of using the suffix. The exam board tend to use the common version where the name system ends in il, propylamine, al, propalamine, propalamine. I don't know. The IUPAC version of the same chemical is propan-1-amine. This is used in the same way as naming alcohols. If the amine is secondary and has two alkyl groups attached to the nitrogen, then each chain is named with the smaller alkyl group. Oh, is named and the each chain is named and the smaller alkyl group is preceded by an N, which plays the same role as a number in positioning a side alkyl chain. In the common naming version, if the chain lengths are not the same, an N is not used. If a tertiary amine, similar rules apply and each alkyl side group is given an N. So this is NN. Dimethyl propylamine, because these two CH3s count as methyls. Okay. It was to be named 1,6-diaminohexane. What? Oh, it's just. Oh, this is. Okay, yeah, I understand. Okay, there's another priority function group as well as the amine group in the prefix amino is used. Okay. Aminopropionic acid. Yeah, that makes sense. Base properties. Primary aliphatic amines act as Bronsted-Lowry bases because the lone pair of electrons on the nitrogen is readily available. Aliphatic. I may have forgotten what aliphatic means. Let's just search that up. Relating or denoting organic compounds with carbon, in which carbon atoms form open chains. No. Oh, right. Okay. Yeah, that's pretty easy to remember. I just forgot that. Primary aliphatic amines act as bronzosylary bases because the lone pair of electrons in nitrogen is readily available for forming a dative covalent bond with a hydrogen and so accepting a proton. Yes, we've seen that many occasions where um, amines are present, such as ligands, that one type of uh, dye. Shoot, I've forgotten, but the ligand that has two NH3 groups on it, or two NH2 groups on it, I think it is. Um, that forms two two bonds to um, the central transition metal. Really forgetting the keywords here. But yeah, okay. Primary aliphatic amines are stronger bases than ammonia, as the alkyl groups are electron releasing. And push electrons towards the nitrogen atom, so they make a stronger base. Okay. Base strength of aromatic amines. Primary aromatic amines such as phenylamine do not form basic solutions because the lone pair of electrons on the nitrogen delocalize with the ring of electrons in the benzene ring. This means the nitrogen is less able to accept electrons. Okay, makes a lot of sense. Links back to our that topic, which is called arenes. There we go. Somehow forgetting the name of the topic there. Reactions with acids. Amines act as bases, react with acids to form ammonium salts. CH3NH2, aqueous plus HCl, aqueous goes to form CH3NH3 plus methylammonium chloride. Okay. That is something I need to remember. Amines as bases react with acids to form ammonium salts. Okay. Addition of sodium hydroxide to an ammonium salt will convert it back to the amine. It's important to remember as well. These iconic salts will be these ionic salts will be solid crystals if the water is evaporated because of the strong ionic interactions. Makes sense. The ionic salts formed in this reaction means that the compounds are soluble in the acid, e.g. phenylamine is not very soluble in water, but phenylammonium chloride is soluble. Okay. Nucleophilic properties. Primary amines can be formed by the nucleophilic substitution reaction when between haloalkanes and ammonia. Makes sense. Reaction with ammonia forming a primary amine. In the first step of the mechanism, the nucleophile attacks the haloalkane to form an intermediate. In the second step of the mechanism, a second ammonia removes a proton from the intermediate, acts as a base to form the amine. Using excess of ammonia can limit further substitution reactions and will maximize the amount of primary amine formed. So something I think I need to do is just memorize the organic reaction map. And I'm hoping there will be maybe a Quizlet thing for that. So maybe if we get this done today, instead of doing energetics 2, I can try and do some It was energetics too, wasn't it? Yeah, instead of doing energetics 2, I could have a go at memorizing that because I do need to memorize it. I should be able to. I mean, I memorized the Oblast of Russia in 1 day, in 3 hours, so I know I'm not that bad at memorizing stuff. I mean, there isn't that many. There's like only like 80, which is pretty doable in that amount of time, to be honest, for most people anyway. But the point is, it should be doable to remember all of those reactions in, an hour or so. I mean, if I can't get them in an hour or two, I can just reinforce it tomorrow or whenever. But it is important to know. Uh, yeah, and I may go through the same thing for um, like the colors of the transition metals and stuff. Alternatively, I could do that off camera, but we'll see what happens. Um, okay, let's go through with this here. Reaction with ammonia forming a primary amine. So to make an amine from a haloalkane, you should just add ammonia. That's pretty simple, to be honest. Um, in the first step of the mechanism, the nucleophile attacks the haloalkane to form an intermediate. In the second step of the mechanism, a second ammonia removes a proton from the intermediate, acts as a base to form the amine. So let's look here. First step, nucleophile, which is the NH3, is attacking the haloalkane. There's the central carbon, or carbon bonded to the bromine, which forms that carbocation intermediate there, where the NH3 is. Wait. Yeah, so the intermediate is with the NH3 because that's a positive charge. Because it has an extra hydrogen there. Because obviously nitrogen doesn't really normally form 4 bonds. And then the second step there, second ammonia removes a proton from the intermediate, acts as a base. So there, the NH3, another ammonia, is taking that hydrogen, which is giving its electrons in the bond to the nitrogen on the amine, the new amine, and that forms an ammonium ion, I'm presuming, which then well, it says acts as a base. Oh wait, no, the intermediate acts as a base. Wait, what? The second step of the mechanism, a second ammonia removes a proton from the intermediate. Yeah, yeah. So the other ammonia is acting as a base there. Yeah, I was gonna say I thought I misread it. Okay. Well, I did misread it. But yeah. So pretty simple. I don't know why I'm spending so long on this. Using excess of ammonia can limit the further substitution reactions and will maximize the amount of primary amine formed. Interesting to know. Reacting primary amines with haloalkanes forming secondary amine. Oh, that's it. Oh, wait, that's very logical. Very logical there. Because, makes sense. Considering what happened in the previous reaction. So we have there the primary amine. There, and you get a diethyl amine in that example. Yeah. There's the secondary amine, and then what is this thing that's produced? That's an ammonium salt, yeah? So, was it just a... Yeah, that'll be what? Ethyl ammonium bromide or something? Guessing. Reacting secondary amines with haloalkenes to form a tertiary amine. The same reaction mechanism occurs with the secondary amine reacting to form a tertiary amine. Yep, I can see how that would work. Reducing nitroarenes to aromatic amines. Nitro group and arene can reduce to an amine group as follows. I remember this. I've checked this recently. You need tin and concentrated hydrochloric acid. Tin catalyst. This is interesting. Why the tin? Well, I know why it has a tin catalyst, but just a bit annoying to remember because tin is quite a niche metal, but whatever. Amides, remember the amides pretty well. It's just a carboxylic acid, but instead of a hydroxide, you have the amine group. Primary amide, ethanamide, or ethanamide, I don't know. N-methyl ethanamide there. Okay, so naming amides, add amide to the stem name. Secondary and tertiary amides are named differently to 2 or 3 carbon chains. A small alkyl group is preceded by an N, which plays the same role as a number positioning into that alkyl chain. Okay, NN dimethylpropanamide. Makes sense. NN2 trimethylpropanamide. Makes sense as well. Formation of amides. Okay, we'll have to remember these. Reaction of acyl chloride with ammonia. Change in functional group acyl chloride to primary amide reagent ammonia conditions room temperature. Okay, yep. Change in functional acyl chloride to primary amide reagent is ammonia. Obviously, on the acyl chloride. Conditions are room temperature, observation white smoke of ammonium chloride is good enough. Okay, very simple. Change in functional group, secondary amide, also acyl chloride to secondary amide, primary amine, room temperature. Okay, pretty simple. Reaction of amides, amide hydrolysis. Primary amides can be hydrolyzed by concentrated acids or alkalis. With hydrochloric acid, an amide will be hydrolyzed and split up into carboxylic acid and ammonium salt. With sodium hydroxide, an amide will be hydrolyzed and split up into ammonia and a carboxylic acid salt. Okay, amide hydrolysis. Primary amides can be hydrolyzed by concentrated acids or alkalis. Hydrochloric acid, ammonia, split up into ammonium salt. Blah blah. Amides can hydrolyze alkalis. The carboxylic acid and amine salt. Okay. Reduction of amides with lithium aluminium hydride. Reduce an amide to an amine by using lithium aluminium hydride and ether, dry ether. This is similar to reducing carboxylic acids and ketones and aldehydes to secondary and primary alcohols. It's the exact same thing here. Very tired. Um, and then just amino acids. All sorts of amino acids. Name amino acids. Zvita ions. Zvita ions. The no charged form of an amino acid never occurs. The amino acid exists as a dipolar Zwitter ion. Amino acids are often solids. Organic interaction between Zwitter ions explains the relatively high melting points of amino acids as opposed to weaker hydrogen bonding that would occur in no charged form. Amino acid exists, yeah. Some amino acids have an extra carboxylic acid or amine group on their R group. These are classified as acidic or basic, respectively, amino acids. Okay. So I'm asking as acidic basic group, then pH value at isotopic point will be different. So I'm presumably if it has a, yeah, it says here amine R group, isotopic point pH greater than 10. Carboxylic acid isotopic point be less than 3. Isoelectric point. What is the isoelectric point again? Let me just quickly research exactly what that is. I know isoelectronic ions are ions that are, I can't type, isoelectric point, are ions with the same charge but of a different atom, so, or different ion, same charge. Not same charge, same number of electrons. Specific pH at which a molecule such as a protein or amino acid carries no net electrical charge and does not migrate in electric field. At this point, molecules at least soluble and often precipitates. Is least soluble and often precipitates. Is calculated by everything. Okay. Not sure you need to know that. And here, acidity and basicity. The amine group and the carboxylic acid group is acid. Amine group is basic and carboxylic. It's acidic, obviously. Species in alkaline solution, high pH. Species in neutral solution. Species in low. In acidic solution, low pH. Yep. Amino acids act as weak buffers and will only gradually change. Act as weak buffers and will only gradually change if pH more so as amino acids. Extra carboxylic acid or amine groups on the R group will also react and change to alkaline acid conditions. Aspartic acid in high pH. Makes sense. Other reactions of amino acids. Carboxylic acid group and amine group. Amino acids can undergo unusual reactions. These functional groups met in earlier topics. Esterification makes sense. Amides, amide. The stem name, I don't know why this is here. This is just this up here, but repeated. Okay, so that's everything there. So now we can move on to the past paper questions. Let's try and get through as many of these as possible. That is decent for you. So maybe we can get to halfway-ish. Okay, so we are starting with sorry. So we're starting with this question about organic compounds containing nitrogen. Sodium cyanide can be reacted with many organic compounds to increase the length of a carbon chain. 1-chloropropane reacts with ethanolic sodium cyanide by nucleophilic substitution. Outline the mechanism for this reaction. Include catalyzed relevant dipoles and the structure of the organic product. Okay. 3 marks. This one shouldn't be too difficult. I believe we covered a bunch of this cyanide stuff in carbonyls this morning, didn't we? For the record, this today is going to be a bit of a bad kind of time. I think we're only going to get about, you know, half an hour done, which will be a yellow on our sheet. Um, However, you know, get it done. Um, and yeah, that's all I have to say. But yeah, let's get on with this. So questions about organic chemistry: nitrogen, sodium cyanide. Yeah, all this. So first, let's draw 1-chloropropane. So how's this related to amines? This question. Not sure, but I will draw it up anyway. So chloropropane should be this, and then the Cl here, and then we are going to draw a outline the mechanism for this reaction. Structure of the organic product. So presumably the cyanide ion donates electrons to this the delta positive carbon. If you can visualize that, I mean, I'm drawing this out myself, so it doesn't matter. The bond then gives its electrons to the chlorine. Then we form a kind of a CN thing here plus Cl minus, which can then react with the which can then bond with the sodium to form the sodium chloride, probably. I don't know how this is amines, but hopefully I got it right. So, where is my pen? Oh, wait, just gotta get the right pen here. There we go. That's not the right pen, but I can use it anyway. So we got the arrows correct here. Got the dipole correct. Got all the arrows correct. So what? Oh, it's only 2 marks? I thought it said 3 marks. This said 3 marks. So where is the hello? Why does it say 3 marks here and 2 marks here? How many do I give myself? 2 or 3? One eye. I mean, I guess I just give myself 3 or 2 out of 2. Well, there's only 2 marking points. Oh wait, there's 3 marking points. Curly arrow from cyanide to carbon atom. Dipole showing carbon bond, correct organic product. And Cl minus. So I suppose I just give myself 3. There's 3 mark points, but it says 2 here. So it should be, and this says 3 here as well. So there should be 3 marks. A bit confused by that, but I'll give myself a 3 out of 3. Because everything's leading towards the 3 marks there. That's one I. Moving on to one II. Compound G is used to synthesize compounds H and I as shown in the flowchart below. Complete the flowchart showing the structure of compound G and the formulae of the reagents for reaction 2 and reaction 3. So, forming, we're oxidizing this whatever this is in the middle, to form a carboxylic acid at the top. I'm removing the cyanide ion. Wait, what? I got no clue on this reaction 3. Let's try reaction 1 here. Sodium cyanide. Well, we can pretty much safely assume this is something similar to what we had before. It would be maybe maybe some kind of why is it acidic though? Is it why does it say slash H plus? Why is it acidic? Shoot. Why do I not know this? Was this covered in the summary notes? I don't think so. Well, I would assume we have something just like this, but with a chlorine instead of CN. That's my guess. Because I unfortunately do not know that. This is where the benefit of learning that reaction map would come in. So I'm gonna put that in as my reaction 1 compound G, compound reagents for comp reaction 2. So shoot, I don't know any of these. Might have to just give up and take the answers to this one. That's why we have these though, because when we didn't know the answers, we have to check. Compound G, I was wrong. So last one we went 3 for 3. This one we go 0 out of 3. So reagents fraction 2 are hydrogen and nickel. So let's look at this here. Hydrogen and nickel. So I don't think that was mentioned in our summary notes, was it? Hydrogen and nickel. Yeah, it's nowhere here. We should be looking for summary notes on what do you call them? Nitriles. But there's nothing on nitriles here. Is nitriles, yeah? Pretty sure it's nitriles. Oh. Not nitrile gloves. Yeah. And we don't have any notes on nitriles here, so it's interesting that we have so much. I wonder if the PMT... Do you reckon they have a separate one for nitriles? Do they just have one for nitrogen compounds? Is this Edexcel? What is CAIE? Wait, we gotta go back. Gotta make sure it's Edexcel. Oh, it's the whole of organic chemistry 3. Okay. Well, acylation. This is not what we're covering. So look, so they have all the normal stuff we just looked at. So amines, etc. Oh, we do have nitriles here. Reduction of nitriles. Lithium aluminium hydride. Did we have that? Did I just skip over it? Well, I obviously didn't skip over it, but I may have kind of just forgotten I'd read it. So we did have um, reduction, but this is a reduction of amides, which is what I thought it was. So we kind of just didn't have reduction of nitriles. To produce an amine. So I'm that is exactly what we're looking for in one of these questions, is it not? Is it that not this one? So is this one reaction 2 lithium aluminium hydride? Nope, it's hydrogen and nickel. So where is that? Like, so this is important. Enzymes such as amides. I mean, I know you can form them from like acyl chlorides and stuff, but I don't see. What is this? Reduction. Yeah, so this is the reaction 3, right? H plus ions and water reflux. HCl be the H plus ions, but there's no. It's just any acid. Okay, yeah. E.g., allow formula of an acid and water. Yeah, so that is. Oh, allow lithium aluminum hydride. Okay, so yeah. Okay, those were correctly identified there. So I guess they're just not mentioned on the summary notes. Bit weird. But you know, it's not a super essential thing as long as we get it identified. And it's good it's in the questions. So yeah, that is that there. And then compound G, reaction of a carbonyl to form. Well, oh yes, this is just in the carbonyls topic. So if we go here and go to carbonyls, maybe we just didn't get to it because we didn't really read through all the carbonyls notes, did we? Well, actually we did. We did read through all the notes, but it's right here at the bottom. I think this is the one we're looking at. Yeah, this is it. So uh, nuclear HCN and this was NaCN, but they have the same effectively the same thing because it's just carrying the cyanide ion. Acidified, I mean in acid. Doesn't specifically say that, but this is an aldehyde technically. So, but this is also an aldehyde. So Okay, so yeah, missed that one. But we move on to what is question 3? Uh, compound H reacts with dilute hydrochloric acid to form a salt. Here. Explain why compound H can react with dilute hydrochloric acid and suggest a structure for the salt formed. So this is an amine reacting with acid, which we know, we should know. Yeah, we do know that. It just forms a salt. Yeah, yeah. Okay, I don't know the explanation, but I'm pretty sure I can figure out the structure. So the structure is going to be NH3 plus Cl minus. So it's going to be like this, but it'll be with an NH3 plus and a Cl minus. I think that's just it, if I remember correctly. OH, I'm just going to draw this out for myself. This is already memorization, this bit, so getting it wrong, I'm not going to beat myself up about a lack of understanding. It's basically just not remembering it. I mean, I could guess I could figure it out, but yeah. So that's the structure. Explanation. There's a dipole somewhere. Oh no, I don't know. That's not. That shouldn't be right, should it? I don't know. Let's look at the answers here because I'm not super confident with this one either. So yeah, it says allow this, which is what I drew. Um, and if charges are shown, both need to be present. That's exactly what I did. So that's one mark at least there. So one, and then it's going to be 1 out of 2 maximum because I didn't answer the other part. Nitrogen electron pair or nitrogen lone pair accepts a proton. Yeah, that is pretty simple. So that's all you have to say. Accepts a proton from hydrochloric acid. Okay, simple. Nitrogen lone pair accepts a proton. Not super complicated, but yeah. Okay, so right now we're on exactly 50%, which is interesting. Oh, that's the answer to the next one. Luckily, I didn't see it. Well, I saw it, but I didn't read it, so hopefully, it's not going to affect my answer. Compound 1, I, not 1, which is here, is the monomer for the biodegradable polymer J. Draw 2 repeat units of the polymer J. Suggest why it's biodegradable. So I know how this is going to work. So this hydrogen is going to go. This OH is going to go. So this will go straight to this oxygen. Or the other way around. I don't think it matters. So what I'm going to draw, just to describe it, is this, and then this, and then this is going to be bonded to here, and then it's going to repeat, and then I think you have to do brackets. Oh, well, we'll find out, I suppose, but hopefully I get some marks if I do the wrong brackets and etc. So the structure was that, so let me just draw that out. H, C. So I suppose I should redraw this in a way that the hydrogen goes on top, just so it's not in the way. And then we've got the carbon, oxygen, double bond oxygen, to an O, to a carbon. And then this is an O, and this is here. And then we've got the hydrogens again, and then the carbon, and then the double bond O, and then that. And that is my repeat unit. And then I have to put N here, I think. And then suggest a reason why it's biodegradable. I don't know a whole lot about. Oh, the bonds can be hydrolyzed by the addition of water. Brackets ester bond or something. Ester linkage. Oh no. Mark scheme here. Okay. That is exactly what I drew, but ooh, no brackets. Oh, N bonds must be shown. Ignore brackets. Yes. Ignore N. Yes. That means they don't care that I did it wrong, technically. Because the ester bond can be hydrolyzed. Yes. Full marks. So is this 3 marks? Yeah, 3 out of 3 there. Wonderful. Huge improvement there. Okay. Oh, wrong thing. 2A. Oh. To be fair, most of the questions we've had so far haven't been on amines, so it's good that some of them are actually amine based. We'll actually take a second for hiatus. I'll be back in a moment. Okay. Outline a mechanism for the formation of ethylamine from bromoethane. Forming an amine from an alkane. This is as simple as it gets. So, let's try and systematically remember this. So we start with bromoethane. Oh, it's a haloalkane. Actually, even simpler, right? Because that's the first one we were shown. So, 1, 2, and then we have a bromine. So how was it working? We just added ammonia, right? Just add ammonia, NH3, and then the electrons from the lone pair on the nitrogen goes to the delta positive carbon, and then the bond, and then the electrons in the bond go from the bond between the CBr bond to the bromine, delta negative bromine. This then forms a intermediate. It's NH3 plus plus the bromine ion. And then the bromine, is it the bromine or is it another ammonia? Shoot. I think it's something to do with another ammonia, isn't it? Another ammonia comes in. Yeah. May have to that'll be cheating though, because I do need to remember this. 4 marks. really should be able to get this. There is another ammonia that comes in. Does it accept? Yes, it does. It accepts so the bond between the nitrogen and the hydrogen in the amine breaks. It donates the electrons from that bond to the nitrogen, and then the hydrogen, and then the NH3 has electrons which it donates to the hydrogen, and then the bond, yeah, and then that works, and then yeah, and then you form um uh uh the amine with the ethylamine with the NH2 plus, and then you have an NH4 um, ammonium ion, which bonds to the bromide ion, so it forms NH4Br, ammonium bromide, or something. That's what I think the answer is. Okay, let's hope we logic that one out. Okay, see how many of the 4 marks we get first. So, first mark is correct. Second mark also correct. Third mark correct. Wow. And the fourth mark also correct. Wow. So full marks on 2A, 4 out of 4. Very good. Managed to get the full marks there. Okay, 2B. State why ethyl amine is formed is contaminated with other amines. Uh, hmm. It's a great question. The ethyl amine formed. What other amines might be forming here? I don't know. I don't know. I have zero clue how to approach this one. So I'm just going to look at the mark scheme. Actually, I should do C first. 2C, and then we'll look at the answer. So this is how our reaction conditions could be modified to minimize contamination. Again, I don't really know what is going on about with the contamination. Like something else is being formed, but I don't know what other amine would be formed, so I'm just going to look at the answer for this one as well. We're just not confident. Further reaction substitution formation of secondary, tertiary amines. Ah, because these can, yeah, okay, yeah, further, because it was, if we get back to our summary notes, reaction of, not this, this is amide still, that's why. Reacting secondary amines with alkenes, which, yeah, these will be still in the, wait, we're producing a primary, here, it's this, so we would produce a, we still have the bromoethane, was it? Yeah, bromoethane. Uh, oh, which is what there is here is the example as well. And we'd have our amine, our primary amine that we made, and they would form the yeah, okay. And then to reduce it, use an excess of ammonia. And what does that do? Ah, so an excess of ammonia can limit further substitution reactions and will maximize the amount of primary amine formed. Okay, so that's basically everything we need to know is right here. And I forgot it, but it's good to now be back remembering it. So if I can write 0 out of 2 for those two. And the answers were um, primary amines will further react to form secondary amines with haloalkane. And the answer to C was use excess NH3, which is logical. Okay, let's go on to 3. How long is 3? It might just do 3 and then end it because we are at 56 minutes and also it is almost 1 in the morning and I need to get up early. So question 3 here. The medicine I I'm my pri I imipramine imipramine has been described as an antidepressant. The structure of the imipramine is shown below. Elephant. The medicine is usually supplied as a salt. The salt is formed when 1 mole of imipramine reacts with the mole of hydrochloric acid. So just why the nitrogen atom labeled B is more likely to be protonated than the nitrogen labeled A when the salt is formed. The nitrogen labeled A is tertiary. That's the first step of the explanation. Is tertiary. So it's more stable. If the marketing says something like ignore references to stability, I'm going to be really annoyed. Because that's the exact kind of thing they'd put in the marketing on the right. Ignore references to stability. But I'm going to say it's more stable. Because it is, I think. And it's more stable while the nitrogen label B is primary, so less stable, and therefore more likely. Oh, it's not. It's also tertiary. I just looked up and didn't even notice that. Oh, the nitrogen labeled A is to do with its positioning, I guess. So I can just remove all of what I've just written because it was wrong. Nitrogen labeled A is what is the nitrogen labeled A? It is closer to the large I don't know. I'm gonna have to look at the answer. Drop some score here because I don't know. Yeah, this is kind of what I was like. This is what I knew. Like this was the explanation, but I just didn't know how to put it. It's more available. Yeah, that's better. That's a good way of putting it. IP or electrons or electron density on delocalized into benzene ring. Oh, we saw that. Yes, we did see that. IP or electron density on. Ethyl alcohol groups that are releasing or donating. Yeah, okay. That's interesting. So, lone pair on A, more available. On B, sorry, more available. On B, more available. Um, Electron density on N, on A. Delocalize into benzene ring. And finally, um, electron releasing or donating. Inductive effect. Push electrons. Methyl groups cause inductive effect on B. Okay, well, that's all for the questions I'll be doing. Let's count up our score and finish it there. So, for amines, it's our first green in the, we have done 60 minutes exactly. Brilliant. First green in this section. Um, what's our score here? 3, 4, 5, 6, 7, 11. 11 is our score out of, we've got 0, 3 here, so 5, 9, 12, 14, 17, 20. Is that seriously 11 out of 20? Is that what I said? 3, 4, 7. 11. Yep. Okay, that's not that good. Kind of lost all my marks at the end there. I was on a really good score until that. But 55 still. Kind of higher than I expected. Actually, no, it's not. 55. 11 out of 20 is very obviously 55. We still get green though because, you know, whatever score we get, it's not about the score. It's about whether we did the questions, which we did. So that's good. So I will have to put none on the video again because I did not watch the video today. But we've done a lot of organics today. I mean, both of them. Energetics 2 we did not work on today. However, maybe I'll get onto it tomorrow and be able to fill that in just off camera because I don't know if I'll have time to do it on camera. To be honest, shall we do some geoguessr? Oh, wait, why is this so... Has this been like this the whole time? Why is it so off camera? Okay. Good enough. Geoguessr time. Oh well, this is a bit of old news, isn't it? Because I'm no longer number 1 in Ireland. I ended up as number 5. 4 points behind Finbar. Very unfortunate. We see where we finished in the world. 201st. Yeah. I mean, we have a few cheaters here, so I mean, can exclude them, like level 32, level 11, level 20. Okay, these are all cheaters. Uh, Hopefully they'll all get banned. I mean, this guy's a 5 streak. He has not been banned yet. Maybe we'll try and... it's a bit just corny to kind of report this person, but... you know, these people do deserve to get themselves banned, so... I forgot to report. There we go. Report player. This player's cheating. I have to link the game. Okay, I can't be asked. This is probably why this person hasn't been reported, because you have to link the game. I mean, it's a bit annoying, but hopefully they're being reported by other people, because, I mean, 5 days, you can't really be getting away with this for 5 days. I mean, how many cheaters do we have here? Well, this guy's clearly not a cheater. Yeah, 0 steps, 6 steps, 0 steps. It's pretty obviously cheaters. 4 steps. This guy's probably a cheater as well. Yeah, definitely. Well, probably. I mean, 25k with 4 steps, obviously. Yeah, 0 steps. We have quite a few. I imagine most of these don't have long. Yeah, 1 streak, 5 streak. Surprising. And then yeah, we got this guy with 5. Okay, well, cheaters are getting away with it quite a lot. But yeah, let's do some AI generated world maybe, or antibiotic. I guess I should be doing, because it is my competitive map this week, and I have to start doing some drills at least. This is the US. Or is it Canada? And where? Well, I have no clue. Like, I know Eastern White Pines is a meta. Are these Eastern White Pines? Maybe. The trees aren't that tall. Maybe we are in, like, over here somewhere. Ontario or something. There's not really any lake, any roads, but there'll be roads in places, won't there? Like here or something. I don't know. Oh, it was New Brunswick. I mean, they were Eastern White Pines, I'm guessing at least, so didn't really go east enough, but okay, so is this... I recognize that, but it's not what I'm thinking, because the one I'm thinking is like Slovakian or something. I can't remember, but with the road, Northern Sun, and the car. I have no clue. With the poles, well, I'm allowed to use a Plunkett guide because I genuinely got no clue whether these poles would make sense for anywhere of these places. Wait, what side of the road are we driving on? Because Kenya drives left, don't they? Driving right, so... Like, how can I not identify whether this is Kenya or not? I really should be able to. But like... This isn't Senegal pole. No, the sun's south. I mean north, so... But like, where is this? Like, the only other place I thought of was Ecuador. I thought of Kenya when I saw this, and I thought of Ecuador. But doesn't Ecuador have an antenna? Okay, maybe not. but the pole is wrong. So is it Brazil? No, it can't be Brazil. But Ecuador is like barely south of the equator, and the sun is super. Ah, actually, it makes sense. Okay, maybe I'll go Ecuador. But like, why is the pole like that? I don't know. It was Paraguay car? I thought the Paraguay car was silver. Am I tripping? Oh, we can't look at. Okay, well, we're on 2,000 score in round three, so this is great. Well, this one's at least easy to get the country, but region, I guess. Maybe it's like north area, like here. It's my 2 cents. Southern road can make sense. There's no hills anywhere, and it's okay. It's completely flat, so it's not gonna be here, but they're gonna be here. Nah, it's Tilly there as well. Is it seriously? Tilly there. Where is it this flat? But it like looks like I don't know. I'm guessing here anyway. It is in Queensland. Well, at least I got the state. Is this New Zealand? No. I don't know. I instantly thought New Zealand here. Oh, it is New Zealand. Oh, I kind of, hmm, I don't know. I was zooming into the sign, not the pole for records. So if I'd seen the pole, I would have known it's New Zealand, but kind of didn't clock that. No, like info or anything. Mm, go North Island here with like the mountains aren't too big, more like hills. Kind of all around. So here maybe what's the road angle? Kind of just west, so maybe here or something, or in a town. So here, I don't know. It wouldn't really be that, would it? I don't know. Okay, it was north. So there was coast north of us. And then last one should be in. This is Mexico, right? Yeah. Just tripped me out for a sec. Okay. Why does this remind me of Monterey again? Like this just, but it's not, I don't think. Might go more south this time. I don't really know. I'm terrible at Mexico, but I'll go there. Well, I mean, at least I didn't go Monterey. Ooh. Okay, 13.7. I mean, I've recently been getting pretty bad scores in this map. I don't feel like I usually get scores that bad, but I suppose it's inevitable. I feel like I recognize that pole. Oh, we have a, that's why it's Turkey. That makes sense. White car antenna. Makes loads of sense. Where in Turkey looks this strange though? Like, is it east maybe? We have hills all around. I don't know. I'd have to click middle here. Okay, that makes sense because it was kind of middle. Uh, Decent start. NMPZ. Nigeria, is it? Yeah. I mean, it's pretty obviously Nigeria. Um, I don't know my Nigerian polls. I don't know if this can tell me anything, but it's dry, so you go north, but not like desert dry, so probably not all the way north, but like pretty north, like north of Abuja, maybe Kaduna. Makes sense. Somewhere in that area. Just click there. Okay, pretty good region guess there. See, look, last round we're on 2k at this point. Bit of an improvement. until we send wrong continent here, but I mean, can't really send anything other than Southeast Asia here, so, or just Asia at least. Um, we have tiled roofs. Can't see anything on that, but the poles definitely feel like Indonesian. I mean, there's a bamboo. Is that bamboo? No, that's just a. Is that no? I would just say Indonesia. Looks plenty Indonesian to me. But I mean, I don't know. Maybe more near Jakarta, because okay, it was there. I mean, tiled roofs. I guess we only saw one, but where's that plate? Where on earth are we? I don't recognize this at all, unfortunately. Why does that look like a... Oh, I know that plate. It's Malaysian. It's Malaysia. It's just Malaysia. Okay. Got saved by the Malaysian flag there because I might have gone something weird there, like Sri Lanka or something. I mean, I do know my plates. I couldn't remember exactly what the Sri Lankan ones were because they have they're just yellow, aren't they? Okay. Well, yeah. So where in Malaysia looks like this? I mean, where in Malaysia looks like this when we have western coast and we're clearly on the main on the this bit. So if we have western coast, I mean, maybe it's this island. That could make some sense. I mean, I've never seen trees like this in Malaysia, so maybe it is this island. Who knows? Let's guess. About as far away as it possibly could have been in Malaysia. Well, at least we know what that looks like now, because I've really never seen coverage like that in Malaysia before. We're already beating last round. Pretty confident here. And does this tell me anything uh, interesting? Don't think so. Except for I don't know what country we're in. Because these are the wrong chevrons for Germany. Where are the German chevrons? Chevron map. Ugh. Map. There we go. Oh, they are German chevrons. My bad, guys. I thought they weren't German chevrons. Okay. Black Forest or just middle click because you didn't know? Middle click was the way to go. And we end up on 18.9k. That is what I call a solid score. I mean, not a good score. I mean, good score is realistically above 20k, isn't it? But solid score, definitely. 14k or whatever we got before, basically 14k, 13.9. Pretty terrible score. I'd say 16k is about acceptable. So yeah, that'll be all for this one. Technically, I could do the daily. Oh, win 5 jewels. I don't think I'll be doing that tomorrow. Okay, that'll be all. And I'm out.